Hey guys, Mr. Gucci here, and this is a help video for your Hydrate mini lab. So to get started, I just made up some data that I'm going to use as an example, and I'm just going to walk through the steps of this lab to help you out. So first of all, in my make-believe lab, I've decided to use CoCl2, cobalt 2 chloride. Some of you all use that. Some of you use the blue crystal, which was copper 2 sulfate. Some of you use the green crystal, which was nickel 2 sulfate. In this case, I'm going to pretend to use cobalt 2 chloride for my calculations. All right, and I got some make-believe data right here as well. The test tubes were about 19.50 grams. I assumed that I started with 3.21 grams of the wet hydrated crystal. After I was done heating it up, I ended up with 1.65 grams of dry cobalt 2 chloride, and that means that I had 1.47 grams of H2O. All right, so with that in mind, let's start the calculations. All right, so here we go. Problem number one. Based on the mass of H2O lost, that's mass in grams, calculate the moles of H2O lost. So we're going from grams of H2O to moles of H2O. So here we go. Let's get this set up. How many grams of H2O did we lose in this? And I'll highlight it with blue, all right, because water is blue. All right, so up here, we see that the mass of H2O was this bottom number right here. So I lost 1.47 grams of H2O when I heated up this crystal. Let's figure out how many moles that is. All right, so I start with 1.47 grams of H2O. I put it over 1. And I want to figure out how many moles of H2O that is. So I need to get out of grams and into moles. So I'm going to put grams on the bottom, and I'm going to get into moles. Now you have to ask yourself, what's the relationship between grams and moles for H2O? Well, 1 mole is whatever the molar mass of H2O is. Let's see here. That's an H plus an H plus an O. We can go to our periodic table and figure that out. All right, it turns out that I have an online periodic table right here. So hydrogen is 1.008. We've got 2 of them, so it's 1.008 plus 1.008 plus an oxygen, which is 16. So when you add that all together, you get that the molar mass of water is about 18.02 grams per mole. Okay, so how many moles of water did we get? Well, it's 1.47 divided by 18.02. So let me plug that into my calculator. 1.47 divided by 18.02. And we have 0.0816 moles of H2O. That's a small number, true. But then again, we didn't have that much H2O. We only had 1.47 grams of the stuff. That's not even a mole. So it makes sense that what we had was significantly less than a mole. So that's how many moles of H2O we had. All right, on to the next question. We have to figure out how many moles, or how much here. We have mass of dry crystal. We have to figure out how many moles that is. So we have to go from grams of dry crystal into moles of dry crystal. Now the dry crystal for us, let's see here, mass of, let's see here, where is that? Here we go, mass of dry crystal right there. For me, I got 1.65 grams, all right? So that's how many grams of dry crystal I have, how many grams of anhydrate I have. So 1.65. So I've got 1.65 grams of CoCl2. Again, that's because I used the purple crystal. If you use another crystal, you're going to have to use that formula. And I need to figure out how many moles of CoCl2 that is. I got to go out of grams and into moles. So let's do that. If I got to get out of grams, grams needs to go on the bottom. Moles needs to go on top, all right? So 1 mole of cobalt 2 chloride is how many grams? Well, I'm going to go to the periodic table again. So cobalt 2 chloride is a cobalt and 2 chlorine. So I'm going to add that together. A cobalt is 58.93 and 2 chlorine. So plus 35.45 plus another 35.45. I get the molar mass of cobalt 2 chloride to be 129.83 grams per mole. And again, this right here, this is for cobalt 2 chloride. If you did this with the blue crystal, copper 2 sulfate, then you're going to have to figure it out with CuSO4. If you did it with nickel 2 sulfate, you're going to have to figure out with NiSO4. But I did it with cobalt 2 chloride, and so that's the molar mass of cobalt 2 chloride. So 1.65 grams divided by 129.83, and I get 0.0127 moles of CoCl2. All right, that's how many moles of cobalt 2 chloride I ended up with. All right, so far so good. So next, we need to figure out a mole ratio. Remember, the goal of this lab is we have some hydrate, in this case, CoCl2, some number of H2Os attached. Is it 3? All right. I don't know. Is it 4? Is it 7? All right. What is it? What is the number of H2Os attached to this compound? Well, to figure that out, we need a mole ratio. We have to figure out how many waters there are for every 1 cobalt 2 chloride. And the way we do that is simple. All right. The way we do it is simple. We just take the moles of H2O that we calculated and divide it by the moles of your anhydrate, your dry crystal. In my case, that's CoCl2. All right. In your case, it might be CoCl2. It might be CuSO4 or NiSO4. Okay, so here we go. It's just moles of H2O divided by moles of CoCl2. So for me, moles of H2O was 0.0816. Okay, that's how many moles of H2O we have. All right, then moles of CoCl2 is 0.0127. So what is that on my calculator? 0.0816 divided by 0.0127. And the answer is 6.43, which, when we round to a whole number, is about 6. Now, what does this represent right here? What does this 6 represent? Well, I'll tell you what it represents. What this 6 represents is that for every 1 cobalt 2 chloride in this compound, there are 6 H2Os. This is the formula of this hydrate. So the formula is CoCl2 dot 6 H2Os. Cobalt 2 chloride, 6 H2O. Okay, now this is what I got. What's the name of this compound? Well, I know what this thing is here because I paid attention in my ionic compound chapter. That's cobalt 2 chloride. And what is the prefix for 6? It's hexahydrate. Hexahydrate. Now, hexa is 6, all right? Here are some prefixes to help you out, all right? Mono, di, tri, tetra, penta, hexa, hepta. All right, so these are the common prefixes. All right, this is 1, 2, 3, 4, 5, 6, 7. All right, octa is 8. Nona is 9. Deca is 10. And if you go past 10, well, listen, you kind of screwed up, all right? Sorry. You shouldn't be going past 10 on this. You'd be wildly inaccurate. So hopefully this is your answer. If my calculations were that this was CoCl2 with 5 H2O, then it would be cobalt 2 chloride pentahydrate. If there were only 4 H2Os, then it would be cobalt 2 chloride tetrahydrate. But since I got 6, it's cobalt 2 chloride hexahydrate. That's what my answer is. This is what this compound is called. All right. So next up, we have to figure out, based on our calculations, what was the percent of H2O in this sample using the data from our table. So we are going to be looking for, what is the percent H2O here? Well, it's the mass of the water that was lost divided by the starting mass of the hydrate. So here we go. The mass of water lost was 1.47, and the starting mass of the hydrate was 3.12. So what was the percentage of water in our compound? It was 1.47 divided by 3.12. Let me double check that. Yeah, that's right. That's right. So again, this is the grams of H2O, and this is the grams total. I like to color code stuff, so I'm going to color code it. So what is the percentage composition of water in my compound? Well, let's see here. 1.47 divided by 3.12. I get that this substance is about, let's see here, 0.471, which is equal to 47.1% H2O. Now, this is what I got. This is my answer. Is this the actual answer? No. There's very little chance that I got things 100% right. Let's see how right or wrong I am. Okay? Now, to do this, you need to get the actual formula of the hydrate. And you need to come to Mr. Gucci for this. Now, let's tell you what the actual formulas are. All right? If you had the CuSO4 as your substance, then the actual formula is CuSO4 5 H2Os. Copper 2 sulfate pentahydrate is the actual compound. Now, if you had the nickel 2 sulfate, the actual formula is NiSO4 6 H2O. All right. And lastly, if you had the cobalt 2 chloride like I did, the actual answer was also 6 H2O. So it turns out that in this sample lab I did, I happened to get the right answer. All right. It wasn't perfect. I had to round it, but I got approximately the right answer. You might get the right answer for your compound, or your answer might be wildly incorrect. All right. And we'll sort that out. So the actual formula for the hydrate in my case was CoCl2 6H2O. Let's calculate the actual percent composition of H2O in the actual compound. So again, this is what I thought it was, 47.1% H2O. What is the percent of H2O for real? Well, for that, we're going to lean back on what your homework was the other night. The percentage of H2O in this compound is the mass of all the waters, and there's 6 of them, so 6 H2Os, divided by the mass of the total compound, CO, Cl2, and 6 H2Os. It's the part divided by the whole. So let me calculate this now. So 6 H2Os, that's 6 times 18.02. That goes on top. And on the bottom, we've got COCl2, which is what? What is it? 129.83 plus 6 times 18.02. All right, very good. So again, it's the part divided by the whole. So now I'm going to get out my calculator. 6 times 18.02. That's 108.12 on top. And on the bottom, plus 6 times 18.02. 237.95. So 108.12 divided by 237.95. The actual percentage of water in cobalt 2 chloride hexahydrate is 0.454 or 45.4%. So this is the actual percent. All right, this is the actual percent composition of water in this compound. This is what I got. This is the actual amount, okay? So we can see that I was actually pretty close, all right? This compound is actually 45.4% H2O. I got 47.1% H2O. So I'm off, but I'm not that far off, okay? Pretty close, good data. Now the last problem here is you actually have to calculate your percent error. And just so you remember how this goes, percent error is the actual amount minus what you got divided by the actual amount, all right? So the actual amount is 45.45. So let's see here, 45.4, yes, there's 45.4% minus what I got, 47.1%, divided by the actual, which is 45.4%. So what did I get? What did I get? Now, by the way, this will give me a negative value, but remember that percent error, you always just make it positive. All right, so 45.4 minus 47.1, I get an answer, divided by 45.4, I get 0.0374, or bounce, bounce, 3.74% error. So that's pretty good. I regret having data that's that good. I don't want you to feel bad. This was all made up, an estimate on the top of my head, okay? You might very well end up with a percent error that's like 50% error. You might get 40% error. You might get some very, very high percent error. Don't be sad, okay? It's okay. So long as you did all your calculations correct, you're going to get full credit. But if you did manage to get the actual correct formula of this hydrate, I'll throw a bonus point your way for funsies. So if you got the actual answer, I'll throw a bonus point at you. But if you didn't, if your percent error was way off, don't worry. I'll give you full credit anyway, so long as you show all your work. All right, guys, so this was a long video. Hopefully you're able to fast forward to the parts that you had trouble with. I wish you luck. Later.